Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we have discussed about stationary random process and first order stationary random process condition. Now here in this video, I am going to discuss about second order stationary random process, nth order stationary random process, wide sense stationary random process and jointly stationary random process. First, we are going to discuss about second order stationary random process. And what is the first order stationary random process? If the first order probability density function of the random process does not change with a shift in time origin, that is independent of time. So that is mathematically fx of x1 comma t1 is equal to fx of x1 comma t1 plus tau for any t1 and any real number tau. That is a first order stationary random process. So now here second order stationary random process. The definition of the second order stationary random process is if the second order probability density function of the random process does not change with time or shift in time value, that is independent of time, then it is called second order stationary random process, and it is given by mathematically fx of x1 comma x2 comma t1 comma t2 is equal to fx of x1 comma x2 comma t1 plus tau comma t2 plus tau. So this is the condition for the second order stationary random process for all t1 and t2 and any real number tau. A second order stationary process is also first order stationary random process because the second order density function determines the lower order. So that is first order density function. So it is a function of time difference. It is a function of time difference t2 comma t1 and not absolute time t. So the stationary condition for a process to be a second order random process is that its autocorrelation function should depend only on time difference and not on absolute time. So time difference means that is t2 minus t1 is equal to tau. So that is a random x of t is the random process. Consider two random variables. If x1 and x2 are the two random variables of the random process x of t, and that random process x of t defined at the time instance t1 and t2 respectively, then the autocorrelation function of the random process x of t is denoted as rxx of t1 comma t2, and it is given by rxx of t1 comma t2 is equal expectation of x of t1 x of t2. So now autocorrelation function depends on time difference. That time difference is t2 minus t1 is equal to tau. So the autocorrelation function only depends on time difference and not absolute time. So that is the condition for second order stationary random process. So t2 is equal, t1 is equal to t and t2 is equal to t1 plus tau. So consider t1 is equal to t and t2 is equal to t1 plus tau. Then the autocorrelation function of the random process x of t is rxx of t1 comma t1 plus tau is equal expectation of x of t1 plus tau. So which is equal rxx of t1 comma t1 plus tau is also denoted as rxx of tau. The autocorrelation function of a second order stationary random process is a function of only time difference. And that is the concept of second order stationary random process, definition, mathematical expression, and condition of the second order stationary random process. Next one is nth order stationary random process. So the nth order stationary random process is also called as strict sense stationary random process. So similarly here the nth order stationary process is defined as If the nth order probability density function of the random process is independent of time, then it is called as nth order stationary random process. So that is n number of random variables x1, x2, x3 and so on xn are the n number of the random variables at the time instance t1, t2, t3 and so on tn. The condition of the nth order stationary random process condition is fx of x1 comma x2 and so on xn comma t1 comma t2 comma and so on tn is equal fx of x1 comma x2 comma x3 and so on xn comma t1 plus tau comma t2 plus tau and so on tn plus tau for all t1 t2 t3 and so on tn for any real number tau. The nth order stationary process means it satisfies all the conditions of lower order stationary process. So all the lower order stationary process mean first order stationary process, second order stationary process and so on. A process that is stationary to all orders that is small n is equal to 0, 1, 2, 3 and so on capital N is called a strict sense stationary random process. So the nth order stationary random process is called as strict sense stationary random process. The next one is wide sense stationary random process. WSS. WSS stands for wide sense stationary random process. A stationary random process x of t is called wide sense stationary process or sometimes called as weak sense stationary process. So the conditions for wide sense stationary random process are first one is the mean value of the random process is constant. So that is expectation of x of t is equal to constant. So this is the condition for first order stationary random process. And the second condition of the wide sense stationary random process is the autocorrelation function depends only on tau and not time t. So that is expectation of x of t plus tau is equal to rxx of tau. So these two are the conditions for wide sense stationary random process. A strict sense stationary random process implies a wide sense stationary random process, but not vice versa. The next one is jointly wide sense stationary random process. Consider two random process x of t and y of t. If they are jointly wide sense stationary, then the cross correlation function of x of t and y of t is a function of the time difference, that is tau is equal t2 minus t1 only and not absolute time. Now consider two random process x of t and y of t. The cross correlation function of the two random process is denoted as rxy of t1 comma t2 and it is given by rxy of t1 comma t2 is equal expectation of x of t1 into y of t2. And the time difference tau is equal t2 minus t1, t is equal to t1, t1 is equal to t and t2 is equal to t1 plus tau. Then the cross correlation function of the random process x of t and y of t is rxy of t comma t plus tau. So this rxy of t comma t plus tau is also denoted as rxy of tau, which is equal expectation of, now here in this equation substitute t1 is equal to t, t2 is equal to t plus tau, we get expectation of x of t, y of t plus tau. So therefore the condition for a process to be a joint wide sense stationary process are mean value of the random process must be constant, that is expectation of x of t is equal to constant and mean value of the random process y of t is constant, that is expectation of y of t is equal to constant. And third condition is the cross correlation function is independent of absolute time. So the cross correlation function depends only time difference tau. So that is tau is equal t2 minus t1. So Rxy of tau is equal expectation of x of t, y of t plus tau. So these are the conditions for a joint wide sense stationary random process.